This is my final lab, Lab 5, the Choose Your Own Adventure lab, and my lab is going to be looking at the physics of collision. So the problem that I chose to investigate is the result of the collision between two objects. The objects that I used are two air-powered soccer discs. They're toys that anyone could use. The questions that I was looking to answer from my video analysis and the simulation or model are whether or not momentum is conserved, whether or not kinetic energy is conserved, whether this is considered an elastic or inelastic collision, and does my model match with my experiment. The results, which I'll discuss in detail in a moment, show that momentum was not conserved, kinetic energy was lost, that this is an inelastic collision, and that the model does not match with my experiment. When talking about momentum and its relation to force, as you can see here, momentum is symbolized by P, defined as mass times velocity. The rate of change in momentum is equal to the net force, which can be shown using Newton's second law. Net force is equal to mass times acceleration. When you're talking about a collision, normally during a collision, the measurements show that the total momentum does not change. So you look at the mass of your first object plus the mass of your second object as well as their velocities, and they should equal the mass and the velocities after the collision. Generally, in all collisions, momentum is conserved, and collisions in which kinetic energy is conserved are elastic collisions. When it is not, those are inelastic. And as you can see, some of that initial kinetic energy is lost to thermal or potential energy. It can be gained in some situations. And a completely inelastic collision is one where the objects stick together afterwards. So there is only one final velocity. That was not the case in this situation. Going along with the momentum principle and the energy principle, I described these earlier, where the net force should be 0, so momentum should also be 0, and final kinetic energy not equal to initial, so the energy is lost. So to determine what happened with my momentum and kinetic energy, I did the following calculations. And as you can see, the total momentum before and the total momentum after are different, showing that momentum was not conserved. And again, with kinetic energy, before and after, kinetic energy is much lower afterwards, so therefore it has been lost. So for my video analysis, rather than choosing to use Tracker, I use the Logger Pro software. And you can see here the video of my experiment, the soccer discs that I was speaking of, and the graph of my data with the velocity initially as well as after the collision, and you can see how the objects changed their direction once they had collided. My model I did using the VPython program, used the different masses of my object, used the data from Logger Pro to establish initial positions, analyze the slope of each position versus time graph to determine the velocity. And you can see here my program, I've used one, followed along with one of the ones we had done previously in the labs. And you can see the mass of my ball, the position, each one was in the velocity mass of each of the balls, as well as the, sorry, that was the wrong program. Here's the correct one, where I didn't use a sliding or rolling friction with these objects. As you can see, for the calculation loop, I used a couple of different times for it to run, and when it runs, you will see there's my first object, first ball coming in contact with the second one, and the resulting change in their courses. Now, as you can see in this graph, they both end up going in the same direction, following about the same velocity. You can see their velocity has increased as opposed to what I actually found in my experiment, where that was not the case. They actually went back in their opposite directions. So in conclusion, based on my calculations, momentum was not concerned in this collision. I believe that's due to the fact that we had to give the objects a slight push or applied force to get them moving towards each other. My kinetic energy was lost. The model does accurately predict the movement of the two objects, but once they collided, that movement didn't match. Again, could be due to the applied force, and they did eventually start moving back towards each other after a few minutes, or a few seconds really. And that is the end. Thank you and good night. Sorry I went over 5 minutes. Had a lot to say.